Okay. So just give me a second. There is a problem with these desktops.
एक मिनट
Hello, Rikshan. So there is a problem with my device, so that's why I've been connected.
Yeah, no problem. So should I make somebody else the host?
Actually, yes.
Who should I make it? Should I make Tejas the host or the other?
The current PC. you can make me presenter like the working right now.
1 second. I'll have to remove you from here. I don't know. I
Just
think
a
you
second.
only can do it because I don't have any more access to it. Wait,
Hello.
huh?
Yes, you can make me presenter like right now. This capital Prathamesh.
Okay, 1 second.
Yes, sure. Uh, just try to. Just.
Okay, I've done. Can
Okay,
you?
thank you.
Yeah, okay. Uh, you can unshare from the earlier thing and share it on this.
Yes, yes. Actually, I'm trying to, but I guess my computer is not responding. Just a second.
Okay.
Yes, it's it. Huh. Okay, thank you. Wait, I shared screen. Or not? Yes. You can see my screen, right, Mandar?
Yes, yes, screen is visible now.
Okay. Right. So yesterday we have seen inheritance, right, in object-oriented concepts, class and objects. So I will just quickly revise inheritance. Just a second. All right. Inheritance. So, sure. How inheritance works is there is a base class which is called as a parent class, and then they let's say parent class may have some attributes like name, let's say parent, and maybe some methods also, like intro. Now, if you want to reuse this function or the attributes of these classes, then what we can do is create a child class and just inherit this base class, which is parent, to our child class, like class, then child, and to inherit any base class, we just pass that class names to our child class. Like here, we want to make parent as our base class, right? So we'll just parent here. No. As we know, init method is used to initialize our class attributes. So I'll just define it. Take name as an attribute, and we'll override the default name with the provided name. Now, so if I make an object of our child class, let's say obj equal to child, and let's say I pass the name as Jack. So what happen is, as you can see, our child class doesn't have any initialization function, right? There is no init. So there is no what we can say, constructor or initializer for our child class. So what child class does is it will look for initializer in its parent class. Its parent class is parent. So there is an initializer in parent class, and it accepts one parameter, which is name. So it will just pass this parameter to its parent class. But if we define any initializer in our child class, then it won't go to its parent class. Then we have to do it manually. So I will again show you that how to do that. But before, now as you can see, child is child can have access to parents attributes and methods also. So even if you make child's object, you can still access the attributes of parent. So I can write print obj dot name. Now name isn't defined in our child class, but it's defined in child's parent class. So child can access parent's attribute and can pass it to its object. If I run it, just a second. As you can see, it's printing Jack, right? And not just attribute, but you can also call the methods, which is intro. Intro is returning name, so which should print the same Jack, right? And let's say if I defined any initialize any constructor or initializer here, then let's say I'm defining address here. Okay. Now what will happen is this Jack will be served as an address for our child class because our child class is accepting only one parameter, which is address, right? So when we create an object of child, this Jack will go as parameter for this init of child class and it will assign as an address. So what happened to the parent's name? So we haven't passed any name yet, right? So this name will be just default name, which is parent. Here, we already defined it. Or you can also define it in parameter as a default name. Let's say it and parent. Now if I run this code, as you can see, I'm printing object.intro. So this will return parent instead of Jack. Oops, there is a error. Child object has no attribute name. So where am I accessing? Oh right. So as you can see, this object is an object is from class child, right? And from class child we are calling intro. Now intro is being called from child, right? But name isn't defined yet because we have just passed address, right? So there is no name in scope of child. So let's say I am passing name also, name and address. So here name and address. But now it will still throw us error, right? Yes, because name is not defined. So what we can do is we can just pass this name to our parent class using either super keyword or just writing the name of our parent class. So let's try it using super. What need? Then this takes name as a parameter. You can see now it's working. So instead of super, you can also write class name. It's parent. But if you wrote class name, then you have to pass self here. Self. It's working. Okay. So it's clear now how we can call a specific parent. Now, even if you had another parent here, we just add, like if this is parent one and parent two, then we'll just have to add parent two dot init. It will call the second parent. So same. So moving on to the next, let's get back to polymorphism. Now, polymorphism isn't same in Python as Java or C++. What in Java and C++, polymorphism stands for the same function with different types of parameters and different types of return signature. Like with same name, function can return either int or float. But in Python, polymorphism doesn't work like that. So if I wrote intro here, intro return, say I'm returning string, hello. As you can see, we have two intro functions. The first one is in parent class and the second one is in child class. Now, if I create another object of our parent, let's say parent equal to parent. Okay, and let's say the name is main parent. Let's print dot intro. Now, as you can see, there are the both functions have same names, intro and intro, but both will act differently here, right? So, child class will return child's method, but parent class will return its own method. Okay, so this is the only polymorphism Python has. Like even if the function have two functions have same name, but they are in very different classes, or let's say in very different scenarios, they will still be act as a polymorphism. So, and even if you like create an init function where you are accessing, let's say, another variable, like in child you are accessing uh, mobile number, which is equal to 123, let's say by default. Okay, and self dot mobile number. Now we can call this init method using two types. Either we can pass mobile number in each object, or either we can't, right? So let's say I'm creating an object with no mobile number. Okay, so let's say child will take name, let's say child and address. I will create another object with mobile number, child, then let's say child 2, also residing in Pune, and he have mobile number 890. Now, as you can see, these both objects are going to call the same function, this init function, right? But one is taking two parameters and one is taking three parameters, and it won't give us any error. Why? Even though they are two different, but we have default value for this, and this even considered as a polymorphism in Python. So that's it. There is nothing more in polymorphism for Python. Now in caps.
One more question.
Yes.
If intro is not present in child class, okay,
Huh.
then it will call the intro of
Parent class. Yes. Yes.
So means what the main image application is.
There is not like a main use, but it can be just represented as one function can be acting different types, right? Like one function can accept two parameters or three parameters. It's the same function or with the same name, but acting differently, right? So
if you want two functions working is different, like add in a child doing addition of suppose string, it is concatenate. Add in the parent, it is doing addition of numerics.
yes,
So name is same, but the purpose is different.
exactly.
So for that, you
Yes.
right?
Right, exactly. So the name is same, everything is same, but the working is different, right? So that's what polymorphism is. Next is encapsulation. So the basic thing about encapsulation is like the mode of encapsulation is what's in class stays in class. So like we have class attributes, right? Like here is a name, then there is address and mobile number. Now, whatever operations we are going to perform on these attributes should only performed in class only. They shouldn't go out of our class. For example, if I want to explain it, let's create another class called temperature. Now definite temp is just a temperature. Whenever we are going to create an object of temperature, we'll be just passing temperature to it. But what is the temperature? Is it degree Celsius or a degree Fahrenheit? User doesn't know this, but class knows what its attribute is, right? So user will be only passing one value. Either it can be degree Celsius or degree Fahrenheit. It's class responsibility to store in whatever format it wants to. Okay. So just a second. I will explain it a little bit more. Just a second. If content self dot type. Okay, so the basic idea behind this is, let's say I'm creating an object called temperature equal to temperature and pass it 35. Now, the basic idea behind encapsulation is we shouldn't be able to do this. What's happening is we are accessing the class attribute directly and we can perform any operation on it, right? Plus, let's say I'm adding +5 to it. Now, what this is doing is the base value of temperature was different in our class, but it's showing different when we print it because we did some mathematical or logical computation with it. So the basic logic behind encapsulation is this should only be done in class only. Okay, so that's why we have terms like getter or setter. So what this means is we should there should be a function which should update the value of our attributes and also sends this attributes value to the outer code, right? So we are updating temperature here outside of our class. We are adding +5 to it. So obviously the base value of temperature is going to change, not in class but in general. So this shouldn't be done. So what we can do is creating another function def, let's say set temp, and accept any value which you want to add in our temperature. Self dot temp plus equal to add. What's happening is if I want to increase the temperature by 5, I shouldn't do this like adding +5 in our print function, but I should actually call that this method which is residing in our class, which is set temp. Temperature dot set temp and add 5 to our temperature. Okay, so what's happening is the value is being changed in class only, it's not changing in outside of the class, and we want to retrieve the value. We shouldn't do this, but instead class call the get function. Okay. This should return the actual value which is residing in our class. Okay, but if I am still able to do like temperature dot temp, why should I create another method to do the same? Now, there can be attributes which should be private and protected. Here comes the concept of private protected variables or attributes, right? And public. Now, whatever this data is attribute temp is public. Anyone can access it just using this object and just object dot the attribute name. Temp dot temperature dot temp will access this temp, right? But if I want to make it private, so only class will have access to it. Then all I have to do is just append underscore in front of it. Okay, and same goes for here.
So underscore is private.
Yes. Is it private or protected? I might have to look it up. But if I append here underscore, then let's try to print set attribute and temperature dot. As you can see, when I press temperature dot, temp is not listed here because we can't access it, right? Because it's a private member. So even though you write in this way, it will still show us error. Oh damn! Wait.
Not underscore.
What underscore shouldn't work. Wait. Underscore. Underscore. Okay. So why is this happening? It shouldn't happen. Okay, so all right. Here is the thing. This is private protected, and yeah, this is protected, right? When you append double underscore, this becomes protected. Now the operations can only performed in class. When we say private, So what's difference in private and protected is when we inherit our class, the private can still be changed, right? It can be accessed, but protected cannot be accessed. Just a second, I will explain it how how it working. Let's say I have name here underscore. And plus self dot underscore name. Try to run it. Just a second. Let me comment it. Okay.
It is double underscore and protected is single underscore.
Okay, let me just write it. Okay. Private is
Private is double underscore.
and protected is single underscore. Okay, so it's this one, right? So the protected can be only changed where class is accessible, and private is only changed within class, not even in its child class or anywhere the child class can be accessed. Still, the private member cannot be accessed via even via object or even via inherited class. So let me show you. Like I have changed some code here. Like in parent class, I have appended underscore in front of name, right? So underscore is protected. So it's protected, and I am trying to access this underscore in child class. So it's working fine. As you can see, Jack, hello, I'm in Pune. But if I make it double underscore, then even child won't be able to access it. Okay. We are getting child has no attribute called underscore underscore name, right? So that's the difference between underscore and double underscore. The one can be accessed within the child class, but and double underscore cannot be accessed anywhere, anywhere other than other than self class. So what we can do is we can call intro. Intro can return name, right? So that's why we are using get and set methods. So instead of intro, this should be get name. So get name is returning name. That's how it works. So let's see, I'm writing here self dot. This will just call the current intro, I guess. Set. Now it's working. Okay. So
If attribute is not just private, okay, but if I have used the method attribute and set method, I can access it in the class even if it is not as private.
yes, but it's class responsibility. Yes, it's class responsibility to handle this,
Okay.
right? So what happening is class is passing this attribute to other child class, or let's say even any other code where we are just calling this function. We cannot access this attribute directly. Now class can modify it, right? And if we are able to access this name directly, then other code will also able to modify this and display something else. But class doesn't on this. Class says if it's my attribute, only I can manage it. Okay, it's my responsibility to change its value, or whatever you want, I will give it to you. So that's the basic idea of encapsulation, that all operations on the attribute should only performed in class. That's it. Okay, so now next is just a second. Mandar, in it out.
No, Prathamesh, till now.
Thank you.
Yeah, welcome.
Now We will take a look at decorators. So what is decorators? Oh wait, abstraction is remaining, right? Sorry. Abstraction. So we're going to start this yesterday, but we had to take inheritance before we start abstraction. So what is abstraction is, we define what we want to create from our class, just like interfaces in Java. Abstractions work same in Python. So let's say I have a class shape. Now any shape class can definitely have an area, right? Any shape has an area. So let's say I'm defining area function in pass, not writing anything in it. Now, if I create another class using shape class, let's say class rectangle, which inherits shape. Rectangle is a shape. And again, defining area here. Return A to B. Yes. Self-topic. Then let's take another class. Class, let's say circle. Shape. It's also inheriting shape. Now, what circle will accept is radius. In it, let's say R. Then self dot R equal to R. Now, as you can see, rectangle have an area method, but circle doesn't have an area method. So there isn't problem in that. Right now, there isn't any problem. So if I'm creating objects called rectangle equal to rectangle with sides of let's say 3 and 4, and there is a circle with a radius of 2. It should work just fine. Everything is working, right? So we have base class which have area method, and we have child class which also have area method, which is inheriting this area method and updating it. Now this can be also called as a polymorphism. Now this area is returning something, but this area is returning nothing. This is also type of polymorphism, right? So inheritance and polymorphism both can be seen here. Now, but when I created a shape class, I want to say that this area method should always be implemented whoever is inheriting my shape class. Okay, like let's say there comes another type of shape which shape doesn't know, and if that type of class isn't implementing area method, then shape have a problem with it. If a shape class says my area method should be implemented in every child, whatever child it is. Now only rectangle is implementing it, but circle isn't implementing it, and there is no restrictions on that. Shape is doing nothing for that, right? So what abstractions mean is, you can specify which functions to define by default. So to create an abstract class, what we have to do to do this is make shape class an abstracted class and make area as abstract method. Now what abstract method does is, whichever class will inherit this shape class will always have to implement this abstract method. Okay. If that doesn't implement this method, then code will show error that you haven't implemented this method, which is important or necessary as per the base class.
All methods in abstract class are abstract methods.
No,
No.
no, no.
Concrete also there.
Yes. So to make an abstract method, we have a decorator,
Oh.
abstract method. So to get started with it, So to define a class as an abstract class, we have to import abstract keyword from Python's base library. Okay. So importing works is here, right? So from ABC import. This statement stands for ABC. ABC is a pre-built package in Python's code, which is already written. And then this package have method called ABC. Sorry, module called ABC. Okay. Now, this module is nothing but just a snippet of code, which is pre-written, just like our functions like sum or anything, which are pre-written and they do some working. Now, to make a class as a abstract class, we just have to inherit it from abstract class ABC, which is an inbuilt function. If you click Control and go hover over it, it will get you to the like implementation of that class. Now, this library is a base library which is written by Python. No, the developers of Python. Okay. So you don't have to worry about how it's working and all. Just to create a shape class, you can just inherit from ABC, which is abstract class. Now, if I run this code,
Import statement we can write anywhere. It is not compulsory.
no, it's not compulsory. But if you are accessing this ABC above this thing, then it won't work. Because as we know, Python runs from top to down, right? Yes. So that's it. If I run it, everything is fine. Nothing happened. So what I have to do is import abstract method also. And just give abstract method as a decorator to whichever method we want to make it as abstract method. I want to implement area method in each of child. So I will just I will write here abstract method. Now, rectangle does have area, but circle doesn't. Let's run the code. Here, can't instantiate abstract class circle with abstract method area. So circle cannot be instantiated. Object for circle cannot be created because circle doesn't have area method. And area is an abstract method which should be implemented in each of shapes child. So when I will implement this area method, everything will work fine. What's an area of circle? It's pi r square, right?
3.14.
What is ABC?
ABC is a base package which is stands for abstract class. So it's you can import the base built classes or code from another repos, which is just import function.
म्हणजे Java जशी library जसं.
Yes, it's just inbuilt libraries.
So we have to import.
Yes. Actually, we are going to learn these models and packages. Then I will explain in depth how is this importing is working. Oh, as right, self.r. Now this shouldn't show any error. Here, everything worked. So that's how abstraction is working. When you declare an abstract method, this should be implemented in each of its side. That's it. That's an abstraction. Now,
Inheritance is also there or no? Inheritance concept in Python.
yes,
It is there.
yes,
It is separate.
yes. Inheritance in Python or
Sorry, not inheritance, interface.
no interface isn't there.
Ah.
Interface concept isn't there in Python.
Prathamesh,
I haven't tried. Yes.
Yeah, only for making an abstract method. So we need to write @ abstract method, right? Or do we write
Yes.
def area and abstract?
Sorry.
For abstract method, so only one thing we need to do, abstract method. So the method will be abstract.
Yes.
Or do we write? Is it possible like for def abstract area?
Yeah. So you are saying that creating our own method, which names
yes,
abstract
yes.
method, right? Yeah,
Yes.
it can be possible, but this is decorator, and the method we are going to write is different thing, right? So actually, decorator is also a method, but the working is different. Okay. So let's
Okay.
try it. Whatever you are saying, let me just write. Let's say def
Abstract, yes.
abstract method, right?
Yes, yes.
let's say this is returning. I'm abstract. Not actually. See what's happening. Method abstract method maybe starting. Here it's running fine. Okay. So what happening is this abstract method. Oh wait. All right. Yeah, it's a decorator. It's a decorator. It's just a method, but it's a decorator. So what decorator does is decorator takes a function as a parameter. Okay. So we are going to learn decorator just after this thing. And this yeah, so what we have done is we have just created polymorphism, right? So there are two methods, which is abstract method as a decorator and abstract method as an our own declared method. So there is a spelling mistake also.
Abstract, yes.
Right. Sorry. So this will still work in my guess, of course, yes.
Okay.
Because there are two methods with same name, abstract method, the one we declared and the one we imported. Now the one we imported will take function as an parameter, as you can see, right? So when we create an decorator, we are just passing this function to as a parameter to this. So that's why this method and this method are different. It's just polymorphism right now we are looking at.
Okay.
And if I try to remove this ABC, actually I haven't tried this before. Let's see what happens. Nothing happened. Okay, I will have to look it up why we are providing this ABC here, because if we can just do this abstract method thing, why we have to do this ABC? All right, I'll search and we'll tell you soon. So the next is, let's get to.
You can try remove ABC and remove that area function.
Yeah, sure.
So
Let's
that
do
can
it.
work.
Oh, right, it's working. So even for abstract method to work, we need ABC.
ABC.
Oh, let's get to decorators. We are doing this either abstract method or the static method, as we did earlier for static explaining static method and instance methods. So how these decorators are working, right? So what this decorator does is takes a function as a parameter and works on the data which is being provided to that function, or does any other operations before calling that function. Let's say I am having a function which is an addition. So before doing addition, I have to check that the parameters which are passed to that functions are either int or not, or if there is any mistake in those parameters. And if there is a mistake, just return from that. And if all parameters are good, then just go ahead. So to like explain decorators more simply, we will just print some statements so that you will get to know how it's working. Let's say I'm having a function def grid. Got a intro. Say intro. Is returning. Return. So there. Good afternoon. Okay. Now, if we just call this method, you can see. Oh, right. Print is remaining. Hello there. Good afternoon. Now, how decorators work? Let's say I'm creating a new decorator for my function. Let's just go through code and you will understand how it's working. Okay. So let's say def my decorator. Now, this will take function as an parameter. Now, this is just parameter name. Okay. You can write anything, only f or I. I'm writing func for more understanding. Func as a function. Now, for decorator, there is inner function within a function. Okay. Nested function. You can also call nested function. Let's say def inner. Now I'm printing something here, print before function. Then I will call this function, which we passed as a parameter. I will explain its working. Write it, print after function. And return. Now, writing this method within a method is a concept in itself. It's a closure, which isn't in our scope of learning what is closure and all. It will just increase our workload. So just look at decorators, how they are working and all. Now, if I said at the rate decorator, let's see what happens.
Print.
Yeah, right. So okay. Now what happened is we called intro. Function will go to intro, but there is a decorator for it, which is called as my decorator. So code will go to my decorator. Okay. So decorator already have an inner function, def inner. Okay. So it will go into inner function. Now there is a print statement, print before function. Here before function is printed. Then there comes print func. Now what is this doing is it's calling this function itself. The function we are passing. In what function we are passing? It's an intro function we are passing to it. So what's written inside the intro function? Return hello there, good afternoon. So it will come here and it will print it. Then it will go next to the after function. So as you can see, there is after function. It will return inner. Inner is just a returning this inner function. So it's a bit overwhelming, like to see it for the first time how it's working. But just remember that whenever we apply a decorator to any function, this function will go as a parameter to that decorator. This decorator will perform some operations and will call this function. Okay. So whenever we call this intro function, this intro function wouldn't get executed just right after we call. It will go to decorator and decorator will call it again. So that's how this intro function will get executed. Okay. So if we remove this decorator, intro will just go here, will go inside this code, it will just run this. But if we apply decorator, then code will go here, but will not go in this function yet. It will say there is a decorator. It will go inside decorator. Then we'll run whatever the code is written inside this inner function. Okay. That's how decorator works. Now we'll look at scopes.
There are some inbuilt decorators.
Yeah, there are inbuilt decorators.
There we can see like inbuilt decorator if you want to see that what code is contained.
Oh yeah, sure. Like we have just mentioned abstract method, right? So let's go to abstract method. Here, a decorator indicating abstract method. Just control. I'm pressing control and hovering over it and clicking on it. It will just go to its definition where it's defined. As you can see, there is a string explaining how this is working. A decorator indicating abstract method usage. We are just using class and then giving this abstraction. Then as you can see, is abstract method true? This is doing just an boolean operation. If that method is abstract method, then it will return true, or else it won't return true or false. Actually, it won't even execute this function. That's it. Yes.
In our decorator.
Yeah.
So, okay, we have defined @ my decorator there at the
Yes.
line number 93.
Yes.
But if I remove that,
Huh.
okay, and below at the 96th page, sorry, line number, if I call that my decorator function, my underscore decorator in bracket,
Yeah. At the calling of function.
so it will work same way.
No. Actually, decorators are for.
No, not at the rate, not at the rate. Just simply
Oh, right.
calling.
Just calling.
Simply calling the function.
Yeah, it will work obviously. But
So
it will throw error, like you have to pass a parameter which is func.
So we can pass intro now.
Yeah, it
So
will work.
It will work same.
Yes, it will work same.
Same.
So instead of writing at the rate, you can call it manually. How? Like let's say intro equal to my decorator and just pass intro. Like this. What's happening is intro is passing to my decorator, and then this is returning this inner function. So now this intro is acting as this thing, right? So now intro's definition is completely changed to this inner's definition. That's how it's working.
My question was, we can pass function to the method as well.
Yes, yes, yes. It's
That
just doing
is
it
not
manually.
happening in Java, right? Function we cannot pass for the method.
I haven't tried, but
No, it's not.
this is just doing manually and applying at the rate it's automatically taking it as a parameter and working on it. We can also like nest decorators, calling multiple decorators instead of nesting. Nesting is the wrong word, but calling multiple decorators. If we are two decorators, we just have to append another decorator here too. So there is any decorator called ABC or anything. Now, how this execution will go is it will first run this ABC decorator, and then it will run this my decorator. So it goes in path. The above one will run before, and the next one will run after. Decorators work. Then there are variable scopes. We learn variable in first session itself, but we haven't covered scopes. Now there are three types of scopes: global scope, local scope, and there is one more scope which is non-local. Now we'll look at this. As we can see, we are writing this code just without any indentation, and it's we are writing it on the very first line or at the very first beginning of this line, right? So if I define any variable here, let's say what variable equal to 10, right? A equal to 10, right? Now this variable will be accessible to all of its indented code. Indented code means whichever code will below this line after this thing, like after this first line to above anything. A can be accessible. Let's say I'm writing here any function def let's say print A, print underscore A. I'm printing A. I will call print A function. Print A. Now we haven't defined this A in this function. We have defined it outside of the function. As we can see, this function is in the scope of this A, right? As this thing is indented to A. So this function should return value of this A, 10, right? And if we do this A equal to 20, now this is a local, this is global. Local means whichever is accessible to the current indentation. Now current indentation, what after this colon, there is indentation of these 4 spaces. Now this A will be accessible to all of this below code with 4 indented, minimum 4 indented code. So this A will print 20, but if I again print A, print this A, outer A. Let's say I will print here inner A.
Instead of A, just take another variable because it will print 10. Yeah.
Here,
The line number 110, it will print 10, right?
yes. Inner is 20 because this A is referring to this A. It's a local. So how actually variables are scanned in Python is it will see for when we are calling this A, it will see for A in its local scope, in its current indentation. Its current indentation is 4 spaces or in this function, printf function. So it will look for A in printf function. If there isn't any A in print in this function, it will go for global scope. And global scope is this, which has A equal to 10. So if this A hasn't been defined, then this will print 10 only. Now, there are some limitations on global and local. So what are those? Okay, so time is almost 12:30. Is it okay if we continue for 5 to 10 minutes? It's just I can cover it in 5-10 minutes. So for global variables, we are reading its data, right? Let me comment this. We're reading value of A from global scope. Is global, it's 10. But what if I want to modify this value? Let's say I want to do a is equal to a plus 10, or let's say plus 30. There is a local variable a referenced before assignment. So where is this a? It's in global scope, but we cannot modify this a. Whichever variables are in global scope, we cannot modify them just by accessing them. To modify them, we have global keyword, global a. What global a does is, it just tells our function that look for a in global scope, only global scope. Don't look for local scope. It will just skip the local lookup and will directly go to the global level. Now global is 10, so 10 plus 30 will 40, will become 40. 40, and even outer it changed to 40.
When we declare that as global,
Yes.
then that time we can keep the local variable also.
No, now a is completely reference to the global variable.
Okay, but if that means that we have commented is equal to 20. If I keep that, so
So if you keep that and we'll do global a, then this a will become global as it has value of 20, and this local will be discarded as Python will look for a in global scope after this line. Let's run it. Let's see what happens. Oh, syntax name is assigned before global declaration.
A is assigned before.
Right. So we cannot assign a local variable when we are assigning global. So it was different. I thought it should modify a. So it doesn't. Nice observation. Right. So this is how we are accessing global variable using global keyword. To update it, we need to use global keyword. And if we didn't route any global, then it will just access like pretend that it's a local variable and will operate on local thing. Now you got it, how global and local are differentiated. Now what is non-local? Let's say there is a function within a function, like we did it for decorator, right? Yes, yes, yes.
that when we declare as local, it will be used, we can use it in same function only, right?
Yes.
In different function I cannot use it.
No. Like let's say I am having
You
a
are talking about this in that also, no?
Yes.
For index.
yes.
But it can also happen that in different function and they will for index. The index will be for on for that index.
No. But the scope, this
will
colon
be a
scope.
multiple function.
Yes.
Element.
For that scope, actually indentation is not the right way to
Right
look
word,
at
yes,
this
right.
thing. It's a scope. It's a scope. The scope is this colon for printf function. Just say indentation for better understanding. Like these are all in same line, so that's why. So it's a scope, matter of scope. Now scope is until this thing. So B will be only accessible for this code only, like, until the function is defined or working. Now here is a B is 20. Now B is just local variable. Now if I try to print B outside of this function, it will just say B is not defined. Here B is not defined, right? Because B is for local scope only.
Pratham is
Same function is what you mean that and printing that local variable.
Yes. Yes. Yes, on that.
yeah, we can access static global variable, right? So we need to make it as a static static
I didn't get
global.
you.
We can
How?
access only like static global variable.
Static global variable, like the
Like,
declared here. So it's a
yeah, we need
static
to declare
declared.
static and then we can call with the static keyword.
No, actually, in my experience, there is no static keyword in Python. So
Okay.
as you are saying, it's a hard-coded A. So it's not like that if you write A equal to 10, you can also do something like take an input from user, then assign it to A in this global scope. And still A will be accessible inside any function.
Okay.
So there isn't any fancy in that, just a simple variable which is declared in outer space and which will be accessible inside any function, inside a whole code as a global variable.
Okay.
I will just take a non-local in just a minute. So let's say I have two functions, outer and then there is the inner. Pass. Now there is a b equal to 10. Let's see. Print B. Printing. Yes. This will happen like let's say I'm giving this b equal to 10 here. Yes. Just a second. So basically the idea of non-local is actually the working is like that. I will just tell you working. The thing which I wanted to try isn't working. I will just tell you tomorrow what I wanted to try. But right now, what is non-local is now the code written in this completely blank lines is for global scope, right? Because it's like the scope for this unindented file is for whole file and which is global, and the code which is written inside function is for local. Let's say I am defining here c equal to 30. So this is for this inner function only, right? Now what if I want to access elements which is declared here, let's say, or b equal to 10. B equal to 10 is for outer function, right? Now for inner function local scope is this and global scope is outside this outer function. Now what if there is a function within that, within local and global, in between? How do we access it? So that can be accessed using non-local. That's a basic idea behind non-local. So what I wanted to try isn't working, so I guess I must have missed some point within it. I'll just look it up again and we'll tell you tomorrow. Okay, is that fine?
Yes.
Thank you.
Can we try to line number 123,
Huh.
print the C,
Here.
enter, one interview. Print C.
Well, actually we have to do it before returning, right?
Okay, huh.
She's not defined. It's is inside this. Okay. I look for non-local again and we'll get back to you tomorrow. Okay. Thank you for today. Okay.
Yeah, thank you.